Hi there, my name is Nicola Tisato, and I am an assistant professor at the Department of Geological Sciences. And I'm also the instructor of the course Computational Applications in the Geosciences, GEO 325G. The course is a computer programming course for geologists. The reason why we want geologists to learn computer programming is that we want to shift geosciences from being an almost entirely qualitative discipline and become it a quantitative discipline. Here we have an example of a qualitative description of a sedimentary sequence in Italy from the 18th century. And on the right-hand side, we have a differential equation which describes the heat diffusion in a material. So I'm sure that Giovanni Arduino, when he drew the sedimentary section on the left, he thought about the earth forces and the processes shaping those rocks, creating those faults and folds. And to describe those processes of deforming those rocks, he had to think about physics and chemistry, and also, of course, mathematics. So the course will help you to learn how to program a computer by using MATLAB. And the course is designed for students who have never been exposed to computer programming. So no worries, we will give you the tools to be able to do some certain calculations and simulations. So we choose MATLAB among many other possibilities. We are not really tied to the language here. We are rather interested in make sure that the students understand and try to think in terms of algorithms to solve geo problems. There are roughly 14 classes, and each class has a laboratory. And the first part of the class, roughly 1/3, is about MATLAB and learning the syntax. So to be able to write codes and solve problems. And the other 2/3 of the class is about cool stuff. It's about to try to solve those geo problems. So we choose MATLAB also because other courses in the department use MATLAB. And this course kind of prepare you to take other computational courses like 325K or 325M, but also courses such as seismic explorations and others. So here are some examples of the cool stuff that you can try to understand and solve using MATLAB or programming in general. For example, we will try to solve linear systems of linear equations. And with that, we can fit data. We can fit observation. In this case, these are ENSO data, which are sea level data in the last 25 and more years. And by fitting this data, we can find the general trend of how the sea raised in the last 25 years, but we also find the periodicity, how this raise has changed year by year. And this is important not only for create an historical archive of the data and try to understand the data in the past, but also to do prediction for the future. Another example is to analyze images. Geologists, they rely a lot on images, and try to extract information from those images is many times key for their research. And here we could, for example, try to understand a proxy of the erupted material, the volume of erupted material, by looking at the colors and analyzing the different channels of the image. Third example is using MATLAB to acquire data in the laboratory. So MATLAB can become a very efficient and good tool to acquire data in the laboratory and to analyze those data. And here we are going to do an experiment where we create an ultrasonic wave which travels through air from the transmitter to the target and then bounces back to the receiver. And by measuring the time of this two-wave travel time, then we can estimate the speed of sound in air. And the last example, which we sometimes do in this course, depends by the year, how the year goes, is to try to understand the heat diffusion in the subsurface. Try to solve a numerically differential equation to understand how the geothermal gradient might change if a heat source is buried at a certain depth, for example. This is an example where we have a nuclear waste repository generating heat, and we want to understand how the geothermal gradient changes after a few thousand years. So I hope to see you in my class, and thank you very much for listening.